Hello folks, and welcome to this lesson on the organic nomenclature of aldehydes and ketones. By the end of this lesson, you should be able to name and draw organic compounds that have aldehydes and ketones as a parent chain. Next up on our list of functional groups that contain oxygen are carbonyl groups. Carbonyl groups are when you have a carbon that's double bonded to an oxygen. Now this carbon can have other things attached to it, of course, but the oxygen, by virtue of having a double bond with the carbon, isn't going to have anything else on it. Now, the title of this lesson is Aldehydes and Ketones, and we still are going to do aldehydes and ketones, but the two of them are actually different sides of the same coin. Both aldehydes and ketones have carbonyl groups. That carbonyl group is what makes an aldehyde or a ketone. The difference is going to be in the naming. Where that double bonded oxygen is going to change whether you have an aldehyde or a ketone, and some of that is because the properties change so much depending on where that carbonyl group is. The aldehyde is when you have that carbonyl group at the end of the chain, and so the R group, the second R group, is basically going to just be hydrogen instead of another carbon. And anything else that has that carbonyl group in the middle of a chain is going to end up being a ketone. You do have a strong dipole because of that oxygen, but it's your aldehydes that are going to have much stronger intermolecular forces compared to your ketones. With your ketones, you have so much and then the oxygen in the middle that it's not as capable of taking advantage of that dipole, so to say, whereas if you have the aldehyde or rather the carbonyl group at the end, as is the case in aldehydes, you can have a little bit more of a clear, oh, this is a much more polar side, this is a less polar side. To look at aldehydes first, in terms of its nomenclature, you're going to look at your hydrocarbon. Notice that carbonyl group is at the very end of a carbon chain, and what you do is you change that very last E into an Al instead. Now, because if you have an aldehyde, that carbonyl group must be at the very end, you're not going to have any numbers for these carbonyl groups. Because it's at the end, it's always going to have to be 1, because don't forget, you're also going to have to give that numbering priority. So lowest number combination, and it's always going to be at the end, it's always going to be 1, so you don't need to use any numbers for that section of the name if you have an aldehyde. Now there may be a way to name an aldehyde as a side chain. I don't even know what it is because I've never encountered it, and you certainly aren't going to be made to do it either. So pause the video, see if you can name this one. Alright, first thing, this is actually a dial because we have carbonyl groups at both ends of this particular hydrocarbon. So that's our parent chain right there. Now in terms of the numbering, there's a little bit of it mattering in this case because as it's going to be equal in terms of the most important functional group itself, now we're going to look at the side chains and see if that makes a difference. And it does in this case. We're going to start naming from the right because that will give us the lowest number combination for our side chain. And this, we have a phenyl group, but it is an ether, so this is a phenoxy. So for our name, we're going to start with our side chains, the number of carbons of our parent chain, no unsaturation to worry about, and then we have a dial. And once again, because we know that our carbonyl groups have to be at the very ends, and there are no numbers for them. So this hydrocarbon ends up being 3-phenoxy-octanediol. Now, as you may have noticed, sometimes the naming or pronunciation of these names can be a little bit awkward because we have our aldehydes that end with Al, but our alcohols end with Ol. And so if you see me and I have to name something for you, you're probably going to hear a lot of over-pronunciation. Now, when it comes to the ketones, same deal, but the ending is O-N-E. So instead of that last E, you put in that O-N-E. However, unlike the aldehydes, your ketones must have the carbon number again, except if it's literally the only possibility. On that note, what do you think the smallest ketone is? Now, ketones won't be named as a side chain either. And here you go. Pause the video and try this one out. Here's our carbonyl group, so you can see that there is a carbon attached and then it has carbons on either side of that carbon, and so that's why it's a ketone. We are going to find the longest chain of carbons that contains that carbonyl group. Our numbering is going to start from the right because you need lowest number combination for that carbonyl group. I'm going to note down what the side chains are and then start naming. Start with your side chains. Now in this particular case we have two different types, so we're going to go with alpha order when we're putting it in the name. The number of carbons in your parent chain, no double or triple bonded carbons, and then our carbonyl group at the very end. So this one ends up being 6-ethyl 7-8-8 trimethyl octan 2-one. Pause the video and try this one out. So here you have a cyclic one. That 6-carbon ring is going to be your main functional group. You also have a carbonyl group, and so that's going to be your most important functional group, and so that's going to end up being the name. But is this an aldehyde or is it a ketone? This ends up being a ketone because our ring is not going to have an N. So if you have our carbonyl group in a ring, it's automatically going to be a ketone. So it's a ketone, that's going to be our carbon 1. We are going to name this so that we have smallest number combination for your side chains, because that's automatically going to be carbon 1. And then you end up with one of those very rare cases where you have a ketone, but you don't need to number that carbonyl group. And this one ends up being 2-methyl cyclohexanone. There's nothing particularly special about naming, or rather drawing aldehydes or ketones. And so that's the end of this lesson. I'll see you next time.